So today we will discuss uh, question number 7. Okay. So question number 7 is assertion is the water content of inorganic soil is determined by heating the soil in an oven at a temperature of 105 degrees Celsius to 110 degrees Celsius. So this is the lab procedure and this statement is correct one. Okay. The reason is the free water, adsorbed water, and structural water are all completely removed from the soil by heating it at 105 degrees Celsius to 110 degrees Celsius. No, only free water and absorbed water is removed at temperature 105 to 110 degrees Celsius, 105 degrees Celsius to 110 degrees Celsius. But but um, the structural water will not remove at this temperature. Okay, for removing structural water, we have to increase temperature more than 400 degree Celsius. Okay, so reason is incorrect and assertion is correct one. Reason is incorrect. So answer will be C for this question. Assertion is correct, whereas reason is incorrect. Okay, so what is assertion? Assertion is true and assertion A, this is true and it is because this is the standard laboratory practice. This is the standard standard laboratory procedure laboratory procedure for inorganic soil for in inorganic soil. So this is important for inorganic soil. Okay, for inorganic soil. This is important for inorganic soil. Heating within this specific range, heating within heating within this specific range, this specific heating within this specific range ensures that ensures that moisture moisture is evaporated is moisture is evaporated without without damaging without damaging the soil particle the soil without damaging the soil particle themselves themselves. Okay, and reason is false. Reason R, that is false, is false because while heating to while while heating to while heating to 105 degrees Celsius to 100 degree 110 degrees Celsius removes removes free water free free water and adsorbed water and adsorbed water and adsorbed water. A structural water is chemically bonded. A structural water is chemically bonded within the crystal structure within the crystal crystal structure of the soil mineral of the soil soil mineral and can only be and can only be only be and can only be removed at much higher temperature, at much higher temperature, often above often above 400 degrees Celsius, which would physically destroy the soil minerals, which would physically destroy the soil mineral, destroy the soil mineral. Okay, so assertion A is correct and the reason R is wrong. So I'm making a table that is very important, and this is very important table. So table, the first column of table is soil type, soil type. Second column is drying temperature, drying temperature, and third column is reason. So if soil is inorganic soil, then drying temperature will be 105 degrees Celsius to 110 degrees Celsius to remove pore pore water pore water without without altering without altering mineral structure mineral structure. And if soil is organic soil, then drying temperature will lie around 60 degrees Celsius, and the reason to remove to prevent the oxidation, that is burning of organic matter, burning of organic matter burning of organic matter. And if the soil contains soil with gypsum the drying temperature will be around 80 degrees Celsius, and this is because to prevent the loss of water prevent the loss of water of crystallization from gypsum of crystallization from the gypsum. So what is gypsum? Gypsum, formula of gypsum is, sometime it is asked in some examination, that is formula of gypsum is CaSO4 with 2H2, two water molecule, CaSO4 with two water molecule, but this 2H2O is crystalline water. Okay, and if you partially heat it, the gypsum, it will become plaster of Paris, and the plaster of Paris is CaSO4 half H2O. This is plaster of Paris, POP. This is plaster of Paris, and this is gypsum. Okay, this is gypsum, and CaSO4 is calcium sulfate, calcium sulfate, anhydride, anhydride. Okay. So this is all about question number 7. So now we will move to next question, that is question number 8. Question number 8. Consider the following clay mineral, that is keylonite, montmorillonite, and elite. Uh, what is the correct sequence in increasing order of their plasticity index? So question number 8, uh, this is similar to question number 5. If you remember that table, according to that table discussed in question number 5, the plasticity of montmorillonite is maximum. This is maximum, and elite is in intermediate, and keylonite is minimum. So increasing order means 1, 3, 2. 1, 3, 2. C is the option. So question number 8, option C will be the correct answer. Okay. Now question number 9. Question number 9. Consider the following statement. Mica is a clay mineral. No. Mica is not a clay mineral. Clay mineral is elite, montmorillonite, and uh, keylonite. But mica is not a clay mineral. It is rock forming mineral. And this is explained, this statement is explained, already explained in question number 6. Already explained question number 6. Okay. And the second statement is the shape of clay particle is usually flaky. Yes, this statement is correct. A particle of keylonite is electrically charged. Or this statement is also correct, and this is also explained in question number 6. So 2 and 3 is correct one, and 1 is wrong statement. So option C will be the answer. Okay. Now question number 10. Question number 10. List 1 deposits, list 2 soil structure, and select the correct answer using code given below the list. So coarse grained soil is single grain. So A will match with 4. Sill deposit, that is generally honeycomb structure. So B will match with 3. Clay clay deposits clay deposits will match with, that is flocculated structure. C match with 1, and D is composite soil. Composite soil is cohesive matrix. So this is 2. So 4, 3, 1, 2. 4, 3, 1, 2. B will be the answer for this question. B. Okay. Let me explain all these options A, B, C, and D. So coarse grained soil is single grained. Okay. So question number 10, single grained structure. What is single grained structure? Let me explain about single grained structure. So I'm clearing first this. What is single grained structure? Single grained structure. So single grained structure is single grained structure. Single grained structure is the characteristic of is the characteristic of coarse grained soil. Coarse grained soil. Okay, with a particle size greater than 20 micron. With a particle particle size greater than 20 micron, and gravitational force predominate. And in this structure, single length structure, gravitational force gravitational force predominate pre predominate the surface forces and hence grain to grain contact result forces and hence grain to grain to grain contact results. Okay, now what about honeycombing? Okay, honeycomb structure. So honeycomb structure. This is for grain of silt. This is for grains of silts smaller than 0.02 smaller than, that is 20 micron, that is 20 micron, and and larger than 0.002 that is 2 micron. Okay, due to due to relative smaller size smaller due to relative smaller size of of grains, the molecular force the molecular molecular forces at the contact area at the contact contact area are large enough are large large enough compared to compared to the submerged weight compared to the submerged weight. So the grain are prevented. So the grain are so the the grains are prevented from from rolling down immediately immediately into the position of into the position of into the position of equilibrium into the position of equilibrium during the process of setting during the process of setting. With that with that they they form they form miniature arches which bridge over relatively relatively large wide space. This result in formation of this result in result in formation of honeycomb structure. Honeycomb, and it will look like this. It will look like this. There is larger voids, and this is honeycomb structure. Okay, so this is honeycomb structure. Okay, so the next is flocculated structure. So what is flocculated structure? Flocculated structure. Next is flocculated structure. Flocculated 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 structure. So this structure is characteristic of this structure is characteristic characteristic of fine grained soil. Fine grained soil, such as clays, such as clays. Interparticle forces play a inter interparticle interparticle forces plays a plays a predominant role plays a pre, predominant role predominant role in the deposition in the deposition. This particle oriented in the particle the particles oriented in the particles oriented in flocculent structure flocculent structure will have edge to face contact will have edge to face contact. Now what is cohesive matrix? So let me erase this part to explain about what is cohesive matrix. Is cohesive matrix. Cohesive matrix. Cohesive matrix. So composite soil in which composite soil in composite soil in which clay particles are very large. Clay particles are very large. Clay particles are very large. as compared to bulky, as compared to bulky, that is large size particle, bulky, comma, coarse grained, coarse grained soil, coarse grained soil particle. Okay, the clay forms a matrix. The clay forms a clay forms a matrix in which bulky grains in which bulky grains bulky grains appears to be floating. Bulky grains appears to be floating, without touching one another, without touching one another, without touching one another. This is cohesive matrix. And coarse grained skeleton is reverse of that. I'm drawing a picture to explain this. Let me remove this portion. Okay. So the cohesive matrix look like this. This is coarse grained soil or bulky. This will not touch each other. And this is clay particles filled around the bulky particles or coarse grained soil. Okay, this is clay particles. This is clay particles. Okay, and this is coarse grained soil. This is coarse grained soil. This is called cohesive matrix. Okay, and the coarse grained skeleton is look like coarse grained clay matrix. Clay is clay matrix, and coarse grained skeleton, coarse grained skeleton look like this. This will touch one another. Okay, load carrying capacity of coarse grained skeleton is more as compared to clay matrix. Okay, and the clay particles will be inside this voids. This is coarse grained skeleton. Okay, so this is all about this question, and the answer for this question is option number B. Option number B. Okay. This is all about question number 10. Now question number 11. Question number 11. Clays exhibit more hygroscopicity than sands. Yes, this is true because the surface area per unit mass of clay particles is more as compared to sand. So hygroscopicity is the phenomena of surface. Okay, so this statement is correct. Statement 2. Clays are colloidal and consequently their specific surface area is very high. So this statement is also correct, and this statement explains statement 1. So answer will be A. Okay. 11, answer will be A. Okay. So now question number 12. Question number 12. Question number 12. At shrinkage limit, the soil is fully saturated. Yes, this is true statement. Statement 2. Montmorillonite clay minerals are non-expensive. This statement is wrong. Montmorillonite clay minerals are very much expensive soil. Okay, so this is wrong. So statement 1 is correct, as statement 2 is incorrect. So option C will be the correct answer. 12, option number C. Okay, now question number 13. Question number 13. Water attached to soil particle through loose chemical bonds are termed as capillary water, gravity water, field capacity. No, this is not. So hygroscopic water will be the correct answer. 13. C will be the correct answer. Okay. Option number C. So let me explain this. What is hygroscopic water? What is capillary water? Gravity water and field capacity. Let me explain in detail. So in soil mechanics, water exists in various forms based on how it is held by the soil particles. Okay. In soil mechanics, in soil mechanics, in soil mechanics, water it exists in various various forms based on based on how it is held by it is held by it is held by the soil particles, the soil particles. So first is hygroscopic water. First is hygroscopic hygroscopic water. So this is the water held. This is the water held tightly on the surface, tightly on the surface, tightly on the surface of soil particle of soil soil particles by adhesion and loose chemical bond. Soil particles by adhesion or loose chemical bonds. Loose chemical and loose chemical bonds, especially hydrogen bonding and dipole-dipole interaction, especially hydrogen bonding, hydrogen bonding and dipole dipole interaction, It forms a very thin film. It forms a very thin, it forms a very thin film around the particle, around the particle, and cannot be removed by, and can not be removed by, cannot be removed by gravity or capillary action. Gravity or capillary action. Okay, this is all about hygroscopic water. This is surface phenomenon. Okay, next is capillary water. Capillary water. It is capillary water. So this water is held in a small pores. This water is held in a small pores. This water is held in a small pores, that is capillaries of the soil by of the soil by surface tension. Surface surface tension. It is the primary source of water for plant. It is the primary source, primary source of water for plant. Now third is gravity water. Gravity water. Okay. So gravity water, also known as free water, also known as free water. This is water that moves through. This is water. This is water that moves through the soil, moves through the soil, moves through the soil under the influence of gravity. Under the influence of gravity. Under the influence of gravity, and is not held by, and is not held by, and is not held by the soil particles, by the soil particles. Now, fourth one is filled capacity. Fourth is filled capacity. Filled. This is not a type of water actually. Okay. Filled capacity. So this is not a type of water. This is not a type of water. It's not a type of water, but but rather a condition, but rather a condition of soil, of soil, rather a condition of soil. It represents the maximum amount of water. It represents, it represents the maximum amount of water, the maximum amount of water a soil can hold. A soil can hold. A soil can hold after excess gravity water has, after excess gravity water water has drained drained away. So let me make a chart for this. So if we take water type in one column, water type, and second column is mechanism of attachment, mechanism of mechanism of attachment, and the third column is for mobility. Okay. So first, water type is hygroscopic. Hygroscopic. So this is loose chemical bond. It is loose chemical, loose chemical bond, and this is adsorption. Adsorption. Immobile. This cannot move. Okay, this is immobile, held very tightly. Immobile, immobile, mobile, and held very tightly. Held very, held very tightly. So this is about hygroscopic water. Next is capillary, capillary water. So capillary water. The mechanism of attachment is surface tension. Surface, surface tension, and moves from wet to dry area. And mobility, it moves, this water moves from wet to dry area, moves from wet to dry area, wet to dry area. Next is gravity water. Gravity water. Mechanism of attachment is gravity. Gravity. Highly mobile, drained out. Highly mobile, and under gravity it is drained out. Drained out. Okay. So the answer will be C. And this is all about question number 13. And this question is asked in Engineering Service Examination 2024. 2024. You see. Okay. So this completes the chapter 3. So from tomorrow we will start chapter 4, and that is compaction of soil. So this is all for today. Thank you everyone.